So 4.7, graph linear functions. So this title is a little bit misleading because it's not a ton of graphing actually in this section. It's more like mathematical, like solving stuff. But there's a little bit. So previously, we've written a function like the equation of a line as y equals mx plus b. And so we just, whatever. But now, we're going to name the function something like f of x is equal to mx plus b. These mean the same thing for all intensive purposes. But this is called function notation. And what this means is the value of f at x. Or you might hear me say f of x. That's the most common way that I will say it. And f of x is just another name for y. So like I said, for all practical purposes, we've already done this section before. It's just being called something a little bit different now to prepare you for what's coming in the future. So an example of what this would look like, it would say evaluate f of x equal to negative 7x when x is equal to 7. So what this is telling you to do is to put 7 in for x. So f of 7, or the value of f at 7, okay, is equal to negative 7, and then anywhere you see an x in the equation, we put 1. So the f of whatever, we don't do anything. That's not like being multiplied or whatever. That's purely its name. Okay, so this, we leave it alone. It's just its name. So the left side is just going to stay by itself. We are just going to multiply the right side. So negative 7 times 7 would be what?
Negative 49.
Yep, negative 49. So the value of f at 7, because that's what we were supposed to plug in, is equal to negative 49. Okay, so that's all you have to do for those, is to solve that. Now, some of the problems that we're going to do are going to give you about 3 to 4 values that you're supposed to plug in for x. And so we'll solve basically in one problem, you're actually solving 3 separate problems. I know why they're doing it, but it's kind of weird when they're doing it. It's going back to, what section was it? Like 4.1 or 4.2 when we were graphing by plotting points, when we were making the table. This is making the table without actually writing the table part. This is just the solving the side part, basically, which will lead up to the graphing. So that's like, it's kind of weird how they did it, but anyways. I'm going to come back to that note later, but today I just want to focus on the solving part, and then we'll get into the graphing part, the little bit of the graphing that's in this section probably tomorrow. So, these say to, so I'm going to write what they say. Evaluate the function when x is equal to negative 2, 0, and 3. So there'll be 3 separate problems that we're solving here. Now, something else I want to point out is that your function can say f of x, it could be h of x, p of x, okay? The letter here doesn't matter. It's just the name of the function. So, like, pretty much all these problems have different letters. Like, a couple of them are repeated letters. That doesn't matter. It's just purely, again, the name of it. So, with number 4, they use g of x is equal to negative 3x plus 5. So we're solving this problem 3 times because we're solving it for negative 2, for 0, and for 3. So I'm going to set up side by side the 3 problems that we're solving, and then we'll actually solve them one at a time. But that way you can see what we're doing. So the function g evaluated at x, and we're going to evaluate at each of these values. So g of negative 2 is first. And again, the left side we just say, that just tells you what's getting plugged in, is equal to negative 3 times, and I will always use parentheses when it's a negative number, especially I will typically use it even for positives, but that way we don't think that it's negative 3 minus 2, and we can see that it's multiplying. Then plus 5. Then I'm going to set it up for 0, so g of 0 is negative 3 times 0 plus 5. And then lastly, we do it for 3, so g of 3 is equal to negative 3 times 3 plus 5. So I don't care if you set them up exactly like this, or if you do one and then set the next one up or whatever, but that way you see what we're doing. So we're solving 3 separate problems here, and so we'll have 3 separate answers for each one. So g of negative 2, this side just stays the same. So negative 3 times negative 2 is what?
6.
Yep, positive 6 plus 5, and then 6 plus 5 is 11. So g of negative 2 is equal to 11. Then over here, g of 0, negative 3 times 0 is 0. So then 0 plus 5 is
5.
Yep. So g of 0 is equal to 5. And then over here, g of 3 is equal to negative 3 times 3 is
Negative 9.
negative 9 plus 5. And then negative 9 plus 5 is what?
Negative 14.
Huh? Negative 9 plus 5.
Negative 14. Or do you subtract?
Subtract.
Okay. 4. Negative 4.
Yep, negative 4. Yep, if they have opposite signs, we subtract, same sign, we add. So that's all you actually have to do for that. You have your 3 separate answers, and they're labeled for which one goes with what. But I just want you to see what this means, because when we get into the graphing, it will kind of help to see exactly what it means. But this is our x value. And remember I said up there, f of x is the same thing as y. Okay, so if I were going to be graphing this, I would do this by points. So the point would be negative 2, comma 11. Okay, then this next point, x was 0, so it would be 0 and y is 5. So whatever the function is equal to is your y value, whatever you're plugging in is your x value. And then g of 3, so 3, comma, negative 4. So those would be your 3 points that you would plot if it was asking you to do that, okay? Now, I'm not going to do that for every single problem. I just wanted you to see, why are we doing this? What is this going to help us do ultimately? Any questions about that one so far? Okay. Seriously, these ones are... Half these problems literally have decimals in them. Like, I don't want to do that. All right, I'm going to modify number 6 to give us a problem that, because I don't want to deal with decimals, because I would give you a calculator for that, and you honestly have one for this. So I'm going to call it 6 modified. So h of x is equal to, it was 2.25. I'm just going to call it 2 times x. And we're still using -2, 0, and 3 for the numbers that we're plugging in. So I'm going to set up 3 separate problems. So this will be h of, and remember that's the same thing like f of whatever. So h of -2 is equal to 2 times -2. Then the next one was 0. So h of 0 is equal to 2 times 0. And then lastly is 3. H of 3 is equal to 2 times 3. So then I just solve it down. So h of -2 is equal to 2 times -2 is -4. H of 0 is 2 times 0, which is
0.
So that one's equal to 0. And then h of 3, 2 times 3 is?
6.
Yep. Any questions about those? So the first section of problems wants you to solve it for 3 separate numbers. Okay, the next set of problems just wants you to solve it for whatever value they put after the semicolon. Okay, but it's basically the same thing. It says find the value of x so that the function has the given, oh wait, scratch that, back up. That's not what they want you to do. Ignore what I just said. Helps if I read the instructions first. These say to find the value of x so the function, and FNCT is how I will abbreviate function a lot, has the given value, okay, which is the number after the semicolon in the problem. So we're doing the opposite of what we just did. Basically, these problems up here, we were given x, we found y. Now we're given y, we're finding x. So we have f of x is equal to 6x plus 9, and it says that it wants it equal to 3. So these are going back all the way to our 1 and 2 step equations like we did on those little flashcards, or that we did right before Christmas break. So all we do is this number here is equal to f of x or to y, however you want to look at it. Okay, it's equal to your function. So I replace f of x with this number. So it's 3 is equal to 6x plus 9. And then I need to solve for x. So what would I do to solve for x? Subtract 9. 3 minus 9 is?
-6.
-6 is equal to 6x. And then what? Divide by 6. So -6 divided by 6 is?
-1.
Yep. And if you want to flip it so that your x is on the other side, if you prefer it to look nice, then you can. But you could also have -1 is equal to x. Same thing. So these are probably actually easier than the first ones because you're just solving, which is we've done for a couple months now. Let's see, 16. H of x is equal to -7x plus 12, and it tells us that it's going to be equal to -9. So now our -9 is our h of x, okay, just whatever the function is called, that's what that number after the semicolon is. So I'm going to replace h of x with -9. Now, if you want your x to go ahead and be on the left to start with, you can write it at the end. So you could have negative 7x plus 12 is equal to negative 9. If you just prefer it to look like that, that's fine. So I need to solve for x, so what do I need to do first?
Add 9.
I want x by itself.
-12.
Yep, minus 12. So negative 7x is equal to negative 9 minus 12 would be what? Negative 21? Yes. Yep, so same sign, add and keep the sign. And then what?
Divide by -7.
Divide by negative 7. So negative 21 divided by negative 7 is
Just
3. Let's see. 18. M of x, so they're just using a different letter again, is equal to 9x minus 5, and they want it to be equal to negative 2. So negative 2 is my m of x, so it's what the whole function is equal to. So again, just because I like the x on the left, I'm just going to rewrite it with this on the right side. So 9x minus 5 is equal to negative 2. And I want to know what x is, so I want to get x by itself, so what do I need to do first? Yep, add 5. So negative 2 plus 5 is, or we can say it as 5 minus 2.
3.
Yep, 3. So 9x is equal to 3. And then what?
Divide by 9.
Divide by 9. 3 divided by 9 would be what?
1/3.
Yep, 1/3. And that's exactly what I want you to do, is just reduce it. And if you get something that can't reduce, you can just leave it. Like, you don't need to like rewrite it as like a decimal or anything unless you just really want to. Let's see. There's one more that gives you a weird answer, so I'm gonna skip that one. But I want y'all to try this one on your own. I'm gonna write the problem the way these last ones have been written. It's not the exact way it's written, but it means to do the same thing. So, 22. F of x is equal to negative 2x plus 25, and they want f of x equal to 5. So try that one for a minute, and then we'll go over it, and we'll save the graphing part for tomorrow. we gotten an answer? What did we get?
X equals 10.
10? Is that what everybody got? You got negative 10? Alright, let's see. I haven't worked it yet, so let's check. Alright, so we set it up equal to 5. So I'm going to subtract 25. So negative 2x is equal to 5 minus 25 would be negative 20. Divided by negative 2. X is equal to negative 20 divided by negative 2 would be positive 10. Any questions about that one? Are we okay with it? Good. Alright, so I'm going to give you a couple here to do, and then tomorrow we'll basically more or less be doing the same thing, but we'll actually plot the points that we get from it. 3, 5, 15 and 17.